Hakes is an open-source high-level multi-platform programming language and compiler that can produce applications and source code for many different platforms from a single code base. Hakes includes a set of common functionality that is supported across all platforms, such as numeric data types, text, arrays, binary and some common file formats. Hakes also includes platform-specific API for Adobe Flash, C++, PHP and other languages. Code written in the Hakes language can be source-to-source compiled into ActionScript 3 code, JavaScript programs, Java, C, C++ standalone applications, Python, PHP, Apache CGI, and Node.js server-side applications. Hakes is also a full-featured ActionScript 3 compatible Adobe Flash compiler that can compile a SWF file directly from Hakes code. Hakes can also compile Neko applications, built by the same developer. Major users of Hakes include TiVo, Prezi, Nickelodeon, Disney, Mattel, Hasbro, Coca-Cola, Toyota and BBC. OpenFL and FLAM are popular Hakes frameworks that enable the creation of multi-platform content from a single code base. With HTML5 dominating over Adobe Flash in recent years, Hakes, Unity and other cross-platform tools are increasingly necessary to target modern platforms while providing backward compatibility with Adobe Flash Player. Architecture Unified language The most unique aspect of the Hakes architecture was the decision to support Flash, JavaScript and the server with a single unified language. In typical web development projects, developers must use many different languages to build an integrated web application, PHP or another server-side language to generate HTML, JavaScript to manipulate HTML on the client side, ActionScript for graphical sections built in Flash, XML or a similar protocol to communicate between the components. Hakes originated with the idea of creating all such aspects in a single language, and simplifying the communication logic between aspects. In a book authored by Nicholas Canis, he states that the original goals of Hakes is the following: build a language more powerful than ActionScript 2 or ActionScript 3, be able to easily port an ActionScript application to Hakes, be able to use this language for Flash 6, 7, 8 and 9, be able to use this language for JavaScript Ajax, be able to use this language for server-side programming, instead of PHP or Java. Compiler The Hakes compiler is separated into one front-end and multiple back-ends. The front-end is responsible for parsing and type-checking the input language, applying macros, general optimizations, various transformations, and for producing the intermediate representation of the code, the typed abstract syntax tree. Each of the backends is responsible for translating that AST into either source code or bytecode for the respective target. The compiler is written in OCaml. It can be run in server mode to provide code completion for IDEs and maintain a cache, to speed up compilation even more. Targets In Hakes, supported platforms are known as targets, which are Hakes modules that provide access to core APIs, for the compiler backends that are responsible for generating the respective code, and for runtimes with specific APIs that go beyond the core language support. Bytecode targets produce executable bytecode that can be executed directly by the runtime. Hakes API and platform-specific APIs available. Language targets produce source code. Most source code must be compiled by a third-party compiler to produce an executable file. JavaScript and PHP code can be run directly, since the runtime uses just-in-time compilation. Inline code written in the target language can be inserted at any point in the application, thereby supporting the entire platform API. Even features missing from the Hakes wrapper API. External modules are type definitions that describe the types of native APIs or libraries, so the Hakes compiler can use static type checking. Performance The Hakes compiler is an optimizing compiler, and uses function inlining, constant folding and dead code elimination to optimize the runtime performance of compiled programs. The runtime performance of Hakes programs varies depending on the target platform. ActionScript 3, Programs produced using the Hakes compiler usually run faster than programs produced using the Apache Flex SDK ActionScript compiler. However, using ActionScript compiler 2 with proper code design, many have reported comparable performance. JavaScript programs produced using the Hakes compiler run at a comparable speed to handwritten JavaScript programs. OpenFL is a common Hakes-powered framework that can run in HTML5 JavaScript, but content built with OpenFL currently suffers performance issues on mobile devices. C++ programs produced using the Hakes compiler rival handwritten C++ programs, but C++ applications built with OpenFL suffer major performance issues. Development of Hakes was started in October 2005 and the first beta version was released in February 2006. Hakes 1.0 was released in April 2006, with support for Adobe Flash, JavaScript, and Neko programs. Hakes was developed by Nicholas Canis and other contributors, and was originally named Haxe because it was short, simple, and has an X inside, which the author humorously asserts is necessary to make any new technology a success. Hakes is the successor to the open-source ActionScript 2 compiler MTASC, also built by Nicholas Canis, and is released under the GNU General Public License version 2 or later. Hakes has much in common with ActionScript 3. The Hakes compiler is developed in the OCaml language. No knowledge of OCaml is necessary to develop applications using Hakes. Advantages to using Hakes include cross-platform abilities, a fully developed high-level language, ability to target modern platforms such as CNET and Adobe AIR, ability to target devices that only support C++. Source code The recommended IDE for Hakes development is Flash Develop, which supports ActionScript 2, 3 and Hakes as first-class languages with syntax highlighting, code completion, and other features. Code folding, code refactoring and interactive debugging is also supported within the IDE. To help leverage existing code, the open-source community has created source code converters for ActionScript 3 to Hakes, C to Hakes, to help build applications in various platforms, or to help convert Hakes code into other languages. The Hakes compiler can compile Hakes to ActionScript 3, Hakes to PHP, Hakes to C++, Hakes to Java, Hakes to C, Hakes to Python. Platform support The Hakes language can compile into bytecode for different virtual machines such as the Adobe Flash Player and Neko, and can generate source code in ActionScript 3, JavaScript, and includes experimental support for C++ and C. This strategy of compiling to multiple source code languages is inspired by the write once, run anywhere paradigm. It also allows the programmer to choose the best platform for the job. The following table documents platform language support in Hakes. Most Hakes programs will function without changes in any given language, although Hakes programs that use platform-specific API will function only in the given platform. Language Hakes is a general-purpose language with object-oriented programming, exceptions, and type inference with class parameters. Generic classes, reflectivity, iterators, and functional programming are built-in functionality of the language and libraries. Unusual among programming languages, Hakes contains a type system which is both strong and dynamic. The compiler will check types implicitly and give compile time errors, but it also enables the programmer to bypass type checking and rely on the target platform's dynamic type handling. Hakes is similar to ECMAScript, although almost no ECMAScript code will run on Hakes without modifications. Unlike ECMAScript, Hakes is a compiled language. Hakes is inspired by ActionScript, Java, and OCaml. Since Hakes had its origins in ActionScript 3, all of the existing Flash API can be used, although Hakes requires better formed code and programming standards than Adobe compilers. Type system Hakes is statically typed. It has a rich type system that offers classes, interfaces, function method types, anonymous types, algebraic data types, abstract types. Classes ADTs and function types allow parametric polymorphism based on type erasure, sometimes also called generics in object-oriented programming languages. Bounded quantification is also part of the feature set. Type parameters can be constrained to a set of 0 or more types. Hakes doesn't offer variance annotations for type parameters. The type constructors are always invariant in their parameter types. Subtype polymorphism is supported via standard, single inheritance. Further, Hakes supports both structural typing and nominal typing. To ease the burden on the programmer, without sacrificing type safety, Hakes supports type inference, which in many cases alleviates the need to write out types explicitly. Classes in Hakes are similar to those in Java or ActionScript 3. Their fields can be either methods, variables or properties, each static or pair instance respectively. Hakes supports the access as public and private, as well as more advanced methods for access control, that are denoted using annotations. Methods and static variables of constant values can be inlined using the inline keyword. Interfaces in Hakes are very similar to those in, for example, Java. Enumerated types enumerated types are a key feature of the language. They can have parameters of their own and can be recursive. They are similar to algebraic data types in languages like ML or Haskell. Technically speaking, they are proper sum types, with the provision that the product types they include must be defined within them. This means they are not simply indexed magic number values as in most languages, and can be used to elegantly solve complex programming problems. Hakes also supports parameterized enums types. Examples of this include Hakes standard library types option and either. Hakes also supports generalized algebraic data types. Anonymous types Anonymous types are defined by denoting their structure explicitly. They can be given an alias by using a type definition. Function types Functions are first-class values in Hakes. Their type is denoted by using arrows between argument types, and the argument type, s, and return type respectively, as common in many functional languages. However, unlike in prominent examples like Haskell or the ML family of languages, not all functions are unary functions, and in Hakes, functions can't be partially applied per default. Therefore, the following type signatures have different semantics than in the aforementioned languages. The type f is a function that takes an int and a string as arguments, and returns a value of type float. The same notation in a language with unary functions only, would refer to a function that takes an int as argument, and returns a function of type string float. Types f2 and f3 denote the same type. Both are binary functions that return a binary function of type f. For f3 the syntax to declare a function type within a function type is used. Abstract types A concept called abstract types is the latest addition to the Hakes type system. They allow to reuse existing types for specific purposes, like implementing types for units of measurement, to greatly reduce the risk of mixing up values of the same underlying type, but with different meanings. The term abstract type as it is used in Hakes refer to something different from a conventional abstract type. The following example assumes that the metric system is the default, while a conversion to miles is necessary for legacy data. Hakes is able to automatically convert miles to kilometers, but not in the opposite direction. As the example shows, no explicit conversion is required for the assignment km equals 100 miles. To do the right thing. Structural typing Structural typing plays a major role in many functional programming languages, and only to a much lesser extent in common OOP languages. Unlike in nominative type systems, the equality of two types isn't established by some kind of name tag, but rather by the structure of a type. Structural types can be thought of as implicit interfaces. See also Mscripton, also on the Hakes platform, Neko, OpenFL, comparison of IDE choices for Hakes programmers, other languages that compile to JavaScript, Dart, Opera, Clojure, CoffeeScript, TypeScript, Scala, other multi-platform languages, Monkey, Bella. References. External links, official website, official Hakes book, Hakes Learning, comprehensive Hakes tutorial wiki, Getting Started with Hakes in FDT 5.0, Hakes Us, an introductory tutorial.